Where does it all begin? How does it all tie together? It may be a DC servo robot. Or a hydraulic plastic injection molding press. Kelch is a division of Bemis Manufacturing. At Kelch, we use electricity in various ways. One of the most evident is the production of light. Others are the generation of heat to melt plastics. We also transform electricity into mechanical motion to apply pressure and assemble products. Starting with our service from We Energies, we are connected to a 27.6 kilovolt switchgear. This serves our substations 1 and 2 transformers. This switchgear also serves as the We Energies metering bay, drawing E11, item 1A, red. A 24.9 kilovolt, 480 volt, 3-phase transformer feeds substation 2. This transformer is connected as a delta-delta. It is an aluminum wound with a turns ratio of 52 to 1. Drawing E11, item 2A, blue. The 480 volts is then fed to a Cooper Power System distribution switchboard. This switchboard is rated at 480 volts, 3-phase, drawing E11, item 3A, green. Also connected to the 480 volts is a Current Technology Select suppression filter system, type SEL200. This device logs any spikes or drops in our incoming voltage. For power factor correction, we also have connected to the line an Autovar power capacitor bank. This is a 480 volt, 3-phase, 60 Hz, 600 k VAR unit that keeps our power factor at 0.97, drawing E11, item 4A, yellow. These devices serve our first and second bays. Here we have a robotic assembly machine. We will discuss the power requirements needed to operate this equipment. This machine utilizes two 120-volt single-phase AC robot controllers. The incoming power also supplies power for a 120-volt single-phase AC microprocessor unit. The drive system for this unit requires 220 volts single-phase AC. We need a special transformer to accomplish this. A Cooper power system transformer feeds our third bay and warehouse. It is also connected delta-delta and is a 29.9 kilovolt, 480 volt three-phase. Its high voltage rating is 24,940 and its low voltage rating is 240. The kVA rating is 3,000, 3360 to 3750, 4200. Drawing E11, item 2B, pink. This transformer requires supplemental air cooling. Also connected to the 480 volts is a second current technology select suppression filter system, type SEL200. Again, this device logs any spikes or drops in your incoming voltage. For power factor correction, we also have connected to the line an AutoVar power capacitor bank. This is a 480 volt, 3-phase 60 Hz, 600 kVAr unit that keeps our power factor at 0.96, drawing E11, item 4B, light blue. The 480 volts is then fed to a second Cooper Power System distribution switchboard, rated at 480 volts, 3-phase. Item E11, drawing 3B, orange. The 480 volts is then run to a bus duct, which runs the entire length of the bay, making it convenient for quick connection of machinery. From the disconnect, it feeds a Cutler hammer, 480 volt delta primary, 208Y 120 volt secondary, 60 Hz transformer with a 75 kVA rating. Drawing E11, item 5B, light green. This voltage continues on to panels 1C, 1D, and 2A. Drawing E11, item 6B, violet. This particular panel is approximately 50% filled. The last step for our transformed voltage is the power black on the robotic assembly machine. The machine utilizes a 3-phase 230 volt 60 Hz motor. However, the variable speed drive requires 220 volt single phase input. Drawing Vibraflight sheet 1 of 13, item 1C, red. Here is a short sequence of events following the molding and assembly of a plastic injection molded part. Here we are using an ABB robot to remove the part from the mold using a vacuum end-of-arm tooling. In this step, we use a CRS robot to assemble a metal link to a plastic latch. Here we use the same robot to assemble the same link latch assembly into a blower housing. In this sequence, we use a second CRS robot to pick up and inspect a filter assembly. Lastly, we use the same robot to assemble